In this section, we're going to talk about synthetic division. Now, this is just a shortcut method of dividing polynomials. Normally, we would use something called long division, and some of you may have learned it that way. I'm going to demonstrate both methods. Something you need to keep in mind, though, is that this only works if we have a certain type of divisor. We have as many terms as we want in the numerator, and we can fix almost anything up in the numerator to make it work. But in the denominator, the divisor, we can only have a binomial, two terms, and the first one cannot have a coefficient. In other words, it has to be a binomial to the first degree. It can't have an exponent bigger than 1, and there cannot be any number other than 1 as the leading coefficient of that variable term. If we have that, then we can use synthetic division, or we can use our long division method that I'm going to show you to divide these polynomials. So I want you to look at this first one. It is a trinomial divided by a binomial, and my binomial fits the criteria. It is just two terms. The first one is two terms, a binomial to the first degree, and the coefficient of the first term is a 1. So I'm okay using this synthetic division. I'm going to show you the long division first. How would you write it if you were going to do long division? Well, you would say, this is my divisor, and I'm going to put it right outside of what I call my division house, and then I'm going to put my trinomial under the house. But I've got to check out my trinomial because it has to have a term for each stage as it goes all the way from whatever the leading, the highest rank is here. I've got x cubed, I've got x squared. I have to have a term that's just plain x, and I have to do that no matter what type of division I'm doing, synthetic or long division. So I'm going to go ahead and set that up so that it will meet the criteria of I can't have a gap in it. I don't have an x term, so I'm going to say plus 0x, and then I'll say minus 8. And this is one of the things that a lot of people forget to do, and it will mess you up. So don't forget, you have to have exponents stepping down by 1 all the way down to your numeric term, if there is one. There doesn't have to be a numeric term at the end. Now, let's look at how we would divide two digits into, or two terms into 4 as it is. And the first answer, the part of our answer, would have to go over the second term, because we couldn't divide a single term by a binomial. So we would have to have at least a binomial divided by this binomial. So I'm going to come out here and put my first answer is going to be here. And then I have to ask myself, this first part of it, the first term is an x. What multiplied times that x would give me 4x cubed? And as you can guess, as you can see, it would be 4 times 4x squared times x would give me 4x cubed. So that's going to be the way I start my answer. So I'm going to say 4x squared times, and I'll say negative 4 here is going to give me a negative 16x squared. And then I'll multiply 4x squared times x, and I'll get 4x cubed. And these have to match because we're going to eliminate these first terms as we work our way down, just like long division. Now, what do you do with long division? Well, you just multiplied, and now you'll subtract. When I subtract, I have to change the signs. And I'm going to say these combine, positive 16, negative 9, to give me 7x squared. And of course, 4x cubed minus 4x cubed is just 0. And that's what has to happen. We have to cancel out the leading term as we go down. Now I'm going to bring down the next term. And as you can see, it had to have an x term in here, or this wouldn't have worked. And that's why we wrote in the 0x. And I'm going to say, what times x would give me this first term again? I'd have to multiply it times 7. And it's going to be a positive 7 times 7, and I'm going to have to multiply it times 7x. 7x times x would give me 7x squared, so I'm okay. I'll do the multiplication. 7x times negative 4 is going to give me a negative 28x. That's why I had to have that x term. And 7x times x is going to give me 7x squared. And now I'm going to change these signs so that I can subtract them in essence. This will be 0 plus 28x, which is just 28x, and the 7x squares will cancel. I'll bring down the last term. And I ask myself the same question, what times x is going to give me 28x? And of course the answer is positive 28. Now I'll do the multiplication. 28 times a negative 4. And if you need to get your calculator out for that one, that's fine. It's going to give me a negative 112. I believe it's right. And I'll say 28 times x is going to give me 28x. And now I will subtract them, change the signs, and combine the terms. I end up with a positive 112 minus 8, which gives me a positive 104. And that's as far as I can go. So this is, in essence, my remainder. My remainder, as you might remember, is always written over whatever I'm dividing by. So what is my answer? Well, my answer to this is 4x squared plus 7x plus 28 with a remainder of 104 over x minus 4. Now let's check out synthetic division, see how we like that. This is a shortcut method, as we said, and it has some rules that I've written down at the top of this page for you. But just to be as a shortcut for you, we first look at our divisor. We know that the coefficient of this term has to be a 1, and so all we really have to pay attention to is this negative 4. We're going to take the opposite of whatever that is. It's a negative 4, so we're going to divide by a positive 4. Now I'm going to draw this house upside down to sort of show we're doing synthetic division here. And then I have to take just the coefficients of these terms. But remember, I didn't have an x term, so I'm going to have to substitute in just like I did there. So I'm going to say the first term coefficient is a 4, and the next one is a negative 9. And the third one is, I'm going to put a positive 0 just to separate it, and the fourth one is a negative 8. So you can see I've lined it up just exactly as I did the long division example. And now the next step is just bring the first term down. I bring it down, and now I'm going to multiply. 4 times 4 is going to give me a positive 16. I will combine these two terms, and I'll end up with a positive 7. I'll multiply again. 4 times 7 is a positive 28. I'll combine those two terms, and I end up with a positive 28. And then I say 4 times 28, and I get a positive 112. When I combine that with the negative 8, I'm going to get a positive 104. Now, it looks like I've got the same coefficients that I have in my answer up here, so how do I figure out what the variables are that go with them? Well, it's always 1 degree less than what we started with. So I started with an x cubed. Now my first term is going to be 1 degree less, so it'll be an x squared. The next one is going to be the next variable, of course, would be stepping down. I would have a 7x, and then I'm going to have the plain numeric term, and finally I will have the remainder, which, as always, I write it over whatever the divisor was, x minus 4. And as you can see, we have the same answer both ways. So synthetic division does take some practice. So I've got another one here, and we can go through this one. I will go through it once more with long division and then with synthetic. I'm checking it to see, does it have 1 degree, does it have a term for each degree? I've got a 4, 3, 2, 1, and just plain numeric, and I'm fine there. It also meets the criteria of it has just a binomial I'm dividing by, and this binomial has a coefficient, leading term coefficient of just 1. So I'm okay to do this, and I'll go ahead and write it out. I'm going to say x minus 4, and it's going to be divided into 5x to the 4th minus 23 x cubed plus 14 x squared minus 9x plus 4. Right, I've got to check it out by saying I need to start over here, start it out like this. There's where my first answer is going to go over the second term because it's a binomial going into this a polynomial. So x times what to get me this first term, 5x to the 4th? Well, it would have to be 5x cubed. When I multiply 5x cubed times x, I come up with 5x to the 4th. It doesn't matter which one you do first. And I'll say 5x cubed times negative 4. Well, 5 times negative 4 is a negative 20. And that, of course, is going to be an x cubed. Now, I've got to subtract these, so I have to remember to change their signs before I combine. And this is a negative 23. Positive 20 is going to give me a negative 3x cubed. And the first term will cancel as we needed it to. The next one, I'm going to bring down the 14x squared. and do the division and do the multiplication again. I'm going to say, what would I multiply times an x this time to get a negative 3x cubed? Well, it'd have to be a negative 3x squared. Let's try it. Negative 3x squared times x gives me a negative 3x cubed. And now let's multiply it times the second one. Negative 3 times negative 4 is a positive 12, and it's x squared. So those match, and that's what has to happen. And I'm changing the signs again. This one becomes positive, and this one, I'll have to scratch it out because it has to become negative. So what do I have? I have 2x squared, and I bring down the next term, which is negative 9x. Now, what times x is going to give me 2x squared? Well, a positive 2x will do it. 2x times x gives me 2x squared. And 2x times negative 4 gives me a negative 8x. Since I'm subtracting them, I change the signs of both of them. And when I combine, I have a negative 1x here. And these cancel. And I'll bring down the final term, which is just a positive 4. What do I have here? Well, really, I have negative x plus 4. Well, what times x is going to give me a negative 1x? Well, just a negative 1. Now watch what happens when I do this one. I say negative 1 times x gives me a negative 1x. And negative 1 times negative 4 gives me a positive 4. And these match exactly. What happens when I change these signs and combine them is I have no remainder. That's kind of cool. So I came through this one clean, no remainder. This is my answer. Let's try it with synthetic division now. I'll come over here and say, I need to start with the opposite of whatever this last term is. It's a negative 4, so I will start by dividing by a positive 4. And now I need all the coefficients written down. I had one for each term, so I've got a 5, a negative 23, a positive 14, a negative 9, and a positive 4. Let's just bring the first one down. And let's do our multiplication. Our first multiplication, 5 times 4, positive 20. Combine these terms. I end up with a negative 3. 4 times negative 3 is a negative 12. So I combine those terms and end up with a positive 2. 2 times 4 is a positive 8. And when I combine these, I've got negative 1. And I say 4 times negative 1 is a negative 4. And of course, when I combine those, I have 0. Now let's look at our original problem. It started with x to the 4th, so we're going to drop that down by 1, and we're going to put x to the x cubed with our first term. And then we're going to say minus 3, and we'll step it down one at a time, x squared plus 2x minus 1. We have no remainder, but our answers match. And that would be synthetic division. Now you can decide which one you prefer. I would practice synthetic division until you are certain that, if you don't want to use it, make sure you don't want to use it, because there are a lot fewer errors made with synthetic division than with long division. I've got a couple more that we can use for examples here. Example 3 has a little bit of a different problem because we're dividing by x plus 1. So we're going to have, and I'm just going to do it with synthetic division here, we're going to have as our divisor here, we're going to have the opposite of a positive 1, which is a negative 1. Now I've got to look at this and see it's not lined up, is it? My problem here is not written in the right order, so I'm going to rewrite it. I'm going to say I need to start with the biggest coefficient. That's going to be 5x cubed. And then I'm going to look for the squared. I have a square term, so I've got plus 8x squared. And then I need just an x term. Well, there it is, minus 8x. And then I've got the numeric term plus 8. Check it out and make sure we've got the signs right, because that can also mess you up. And since those are correct, I'm ready to set the coefficients inside my divisor house. I'll put a 5, a positive 8, a negative 8, and another positive 8. So I'm going to bring down the first one, and then I'll multiply. Negative 1 times 5 is negative 5. Combine these two, and that gives me a positive 3. 3 times negative 1 is negative 3. When I combine these two, I've got a negative 11. Negative 1 times negative 11 is going to give me a positive 11. And when I combine these two, I get a positive 19. So what is my answer? Well, I started here with x cubed, so my answer will begin with an x squared, down 1 degree. The next term will have to be an x term. The next term will have to be plain numeric, and that term, the final one, is a remainder. I put it over the divisor, which is x plus 1. Okay, one more example for synthetic division. And this time I check it and I've got an x squared, I've got an x term, and I've got a plain numeric term, so I'm okay. I don't have to add any terms in here. And I'm dividing by x minus 5, so I will use a positive 5, the opposite of it, remember. And I'm going to write my coefficients. Well, this one is a coefficient of 1, and this one is a coefficient of 1, and then I have a negative 30. I'll bring down my first one and do multiplication now. 5 times 1, positive 5. I'll combine these. 1 plus 5 is 6. I'm going to write the plus in. 5 times 6, positive 30. When I combine these, I have 0. So what is my answer? Well, it started as x squared, so my first term here is just x term, 1x. And then the next one is just a plain numeric term, right? Because 1 down from x means x to the 0, which is just 1. I don't have a remainder for this one, so the answer is x plus 6.